welcome back to Solving Problems Together. Today, we're going to get started with a problem involving indices and a fraction. Now, this one was submitted as a request to be featured on the channel, and wherever I can, I'm happy to do so. Now, as always with problem solving, it's good to take some time and think about what maths you might need to use. So, the first few things that come to mind are that I'm going to use index laws. We have some complicated looking indices. Index laws may well help to simplify. We're likely to form and solve an equation since we have x's and unknown values. And lastly, I notice I have x squared and just an x, so I'm likely to have a quadratic equation appear at some point. Let's make a start. Now, the first thing I want to do is to see if I can rewrite any of these other terms with a base of 5. I know that my index laws only hold true if the bases are the same. So, starting with the denominator, I know that I can express 25 as 5 squared. And the number 625, I recognize that that is 5 to the power of 4. 5 squared is 25, 5 cubed is 125, and 125 times 5 to the power of 4, that is indeed 625. So let's rewrite some of these terms. Now that I have everything with a base of 5, I'm more confident that I can manipulate these into something useful. I have 5 squared to the power of x. I can remove these brackets and I would have 5 to the power of 2x. I'm now dividing two terms which have a base of 5. Whenever I'm dividing and the bases are the same, I can subtract the powers. So I can rewrite the left hand side as 5 to the power of 2x squared minus 2x, and that equals 5 to the power of 4. Since these both have the same base and are equal, I can determine that the powers themselves must be equal. 2x squared minus 2x must equal 4. And there we go. We now have a useful quadratic equation. I'm going to rearrange this and see the difficulty level of solving this quadratic. Getting it into the general form, I notice that 2 is a common factor. I'll factorize out the 2. And now in the brackets, something which I recognize can be factorized quite easily. To form the brackets, I need two numbers that multiply to give me -2 and add together to give me -1. So those numbers are -2 and +1. In my brackets, I'm going to have x subtract 2 and x plus 1. And we're one step away from solving. For the left-hand bracket to equal 0, x must equal 2. And for the right-hand bracket to equal 0, x must equal -1. And there we go, my two solutions for this problem. Now, as always, it would make sense to substitute in to make sure that my proposed solutions do satisfy the situation, do satisfy the original equation. And I've done that, and they do. And there is something interesting to notice there. I'll leave you to substitute into the original equation, and when you represent both the numerator and denominator with base 5, there's something interesting that happens with the values of the powers, the difference between the values in the powers. You can let us know in the comments if you notice what I did. Thanks for joining us today, and I hope you enjoyed following along as we tackled this problem. If you have any other thoughts or approaches you'd like to share, then we would love to hear about them in the comments. There's always more than one way to solve a problem, and the different approaches and the different takes on a problem are actually what make problem solving so intriguing and enjoyable. Thanks for joining us, and we'll see you again soon for more problem solving.